keren doctoraten. Dus we zijn heel blij dat ze hier is vandaag. En we hebben ook de kans om als zaal, als deelnemers van vandaag, haar nog een paar vragen te stellen. Dus u kunt straks naar haar luisteren met al in het achterhoofd het idee, nou, als ik echt nog iets te vragen heb of iets niet snap, dan is daar ruimte voor. We proberen in ieder geval in de zaal nog zeker 10 minuten met haar in gesprek te gaan. Dus die mogelijkheid is er. The neuroscience revolution. Baroness Susan Greenfield, we are very honored to have you here today, and the floor is yours.
Goedemiddag. I'm very sorry, but that's as far as we can go in Dutch. And I do apologize. I gather I'm the first and last speaker who can't speak to you in Dutch. So I'll try and talk slowly, but when I get very excited, I tend to speed up, and I don't get offended at all if you go like this, something. Okay, so what we're going to do is look really at how neuroscience and advances in neuroscience can really help us understand the opportunities and challenges that I will argue are really very special to the 21st century. And I think the first issue really, and perhaps something I'll be coming back to again and again, is the notion of the individual, the notion of the individual mind, the thing that makes you so special. And if we're to start with that very exciting issue, then surely the first question is, well, is it all in my genes? I'm sure everyone is familiar with the old distinction of nature versus nurture, of environment versus the genes. And so perhaps the first issue to focus on is, for the human especially, the absolute significance and importance of your environment. That's not to say that genes aren't important, but what I want to establish first is that what we must do is put almost literally genes in their place. You can see here DNA, but can you see trapped inside that DNA being clever, or being kind, or being unpleasant, or being in a bad mood? Of course you can't. Because although genes are important to brain function, it really is the interaction of the genes with the whole landscape of the brain that makes you the special person you are. And what I want to show you is even with rats, you can see a difference. Now, why am I suddenly showing you this slide on Huntington's disease? It used to be called Huntington's chorea. I'm sure everyone has heard of this. It comes from chorea, the Greek for dancing, because as you can see on the right of this unfortunate person, the person presents with wild, involuntary movements of the limbs in a grotesque form of dancing. And as you can see on the left, if you have this gene, you have the bad gene, you will have the movement disorder that we call Huntington's disease. Now, the reason I'm mentioning this is that this might be an extreme example of where, yes, a gene trumps everything. That whatever happens, if you have that bad gene, independent of your environment, then it will give you, eventually in middle age, this movement disorder. But not quite the case. Here's a very interesting study, and this I hope proves my point, in mice even, where so-called transgenic mice were studied. That's to say, mice where the gene had been deliberately manipulated, so they had the mouse equivalent of the movement disorder. Why is this that interesting or exciting? Well, the whole point was to see, even here, even with little mice, even with a single gene, where surely the destiny was certain, could there possibly be a difference if the environment was varied? So here you see the simple lab cage for the mice, compared to what we call an enriched environment. An enriched for a mouse doesn't mean to say they come to a meeting for the day in Amsterdam and have lots of workshops and interactive discussions. They have a much more modest goal. And enrichment for a mouse, as you can see, are little tubes and wheels and things to play with and a bit more space to interact. That is the only difference. And what we're going to look at now is the movements of the mice compared to the enriched environment with the standard environment. And what we're going to see is a score on the vertical scale. The higher the score, the worse the movement, and how that progresses over the days of the mice life. So here you can see, as always, the controls. These animals were completely normal, their genes were not tampered with, And as you can see, as they're aging, they are scoring 0 because they are moving just fine. However, their counterparts who are in the standard housing are living out their genetic destiny. And as you can see, as they are aging, their movements are getting worse, the score's getting higher. But the group we're really interested in, aren't we, are those that had the genetic problem, but were living in an environment that was enriched, and this is them. And as you can see, the onset of the disease is much later, and the degree of the impairment is much more modest. So this is my first point. If for a little mouse with a single gene disorder, merely being stimulated by a few little ladders and wheels, you can see such a difference of the environment, how much more for you humans? Now, the wonderful thing about being born a human being, therefore, is, let's say, compare yourself to a goldfish. I don't know if there's any goldfish lovers here, but let's be honest, goldfish don't have great personalities, do they? I mean, one could say, let me be brutal, say your children had a goldfish and the goldfish died, you could go and buy another goldfish while the child was at school, and they would come home, and they wouldn't know any difference. Yeah? You couldn't do that with a pet cat or dog, and even if they might want you to, you certainly couldn't do it with their brothers or sisters. This is because as we become more sophisticated in the animal kingdom, so we shift away from the dictates and the stereotyped behavior of the goldfish determined much more directly by the genes, to something that we human beings do fantastically. We don't run particularly fast, we're not particularly strong, we don't see particularly well compared to some species, but we do something superlatively, and that is we learn. We adapt to our environment, which is why we as a species occupy more ecological niches than any other on the planet. So the second thing to establish, having, I hope, put genes in their place, is that the human brain, more than any other species, does something fantastic. It adapts to whatever environment in which it is placed. This is something called plasticity. It doesn't mean that literally the brain is made of plastic, but rather that it comes from the Greek plastikos, to be molded. So let's see how this happens. And I'll call this, if you like, the mind, the growth of the individual. So this is how you started your life. This is the first 2 years of life. And for those of you, I suspect most who are not neuroscientists, you may not be familiar with this kind of picture. So the blobby bits are the brain cells, and the lines, the stringy bits are the connections. And you can see here the newborn, the 3-month, 15-month, and 2-year human brain, characterized not by the growth of lots of brain cells, but by the connections between them. Now this means that even if you are a clone, an identical twin, you will have a unique pattern of brain cell connections. And the reason for that is because these connections are shaped and stimulated and responsive to your individual experiences. So let's have an example of this, and I love this experiment. It involves 3 groups of adult human volunteers, none of whom could play the piano. Now, if ever you get to volunteer for this kind of experiment, let me give you a word of advice. Don't be the control group, because they just had to stare at a piano for 5 days. Pretty boring for them. Much more exciting was to be in the experimental group, and they learned 5-finger piano exercises. And what we're going to look at are the brain scans over 5 days, where we can compare the effects of merely staring at the piano with learning piano exercises. But even more exciting still is a 3rd group, and I'm going to keep them as a surprise. Okay, so look first at the top panel. As you can see in the controls, nothing's happened over 5 days. The brain is literally unimpressed by this. However, look at the people with the 5-finger piano exercises. You can see, even over 5 days, an astonishing change in the functional brain territory that relates to the digits. Even over 5 days, you can see a huge difference. But the exciting group, my surprise group, are the 3rd group, because this group merely imagined they were playing the piano. And can you see their brain scans almost identical to those who actually played? So what does this tell us? This tells us the exciting thing here with modifications to your brain territory, to the status of the connections, is not the contraction of the muscle. It is the thought that has preceded it. And someone once said, the man who worked and developed a treatment for Parkinson's disease, a man called Hornikowitz, he said, thinking is movement confined to the brain. Thinking is, and you can see here, thinking is movement but confined to the brain. Now, what's the basis of all this? Well, again, in order to understand what's happened in those human brains, if we're going to look at, and this is what I do, is to look at the actual hardcore brain cells, we need to go back, in this time, to rats. And this is from my own lab. Again, this time you can see rats rather than mice, but you can see the so-called enriched environment. So look how happy these rats look. If you're familiar with rats, you're aware they're obviously very, very pleased to be in the enriched group. And then, if you look at a single brain cell from a rat in a more standard house compared to a rat from an environment such as this, we can see an exciting difference. So this is a single brain cell, and again, for those of you not familiar with brain cells, I want to draw your attention to the branches that are coming out of that blobby thing. And compare that with these from the enriched. Now what's happened here, as you can see, in the brains of animals that have had that interactive, enriched environment, there are more branches, they're more extensive, and they are larger than in the isolated counterpart. Why is this? Well, this is because your brain is like the rest of your body. In a way, it's like a muscle. The more it's made to work hard, exercise, the more it will grow and be strong. Now, the way a brain cell does that is not to get bigger in terms of the main part of the cell, but as we can see here, to grow more branches. So the more active a brain cell is, the more stimulated it is as you're interacting with the environment. So what happens is branches grow. Now, why is that interesting or important? The reason is you are increasing the surface area of the brain cell. And if you increase the surface area, what happens then is you can make more connections, because more brain cells have the chance, more neurons have the chance to make contacts with this target brain cell. Up to 100,000 brain cells can make connections with any one single neuron. So let's just recap that. A stimulating, interactive environment, like with the piano players, like with the rats, makes the brain cells work harder, in turn makes the branches grow, in turn increases the surface area, in turn enables the possibility of more connections between brain cells. So you see how we've gone from the environment to the neuroscience, and how we can explain and understand what's going on with those piano players. Now let's think, therefore, about our own lives. You're born, in the words of the great psychologist William James, into a booming, buzzing confusion. And what do? You evaluate the world, because you can't do anything else, in terms of raw senses. How sweet, how fast, how cold, how bright. But gradually, as you're a small child doing that, looking at the world in this sensory, this raw sensory way, you can imagine a certain visual pattern persisting, constantly being there. And that visual pattern, let's say it's a face, will be accompanied by certain voice tones, certain textures, certain smells, possibly certain colours. So gradually you will get used to these previously abstract sensations. If they are presented time and time again together, you'll make connections between them. And slowly you will shift from a world of a confusion of raw senses to something that starts to mean something to you. Now here you see me with my colleagues, and I've deliberately chosen my colleagues because here they are, they're white, middle-aged scientists. Men, of course, yeah? This is what they all look like in England. I don't know if Holland has different looking men, but these are the English ones. And you can see that, I mean, they're all very nice, but you will see them as white, middle-aged men in suits and ties. I see them as David and Tim and Martin and so on. And I know their wives' names, I know how many children they've got, I know what their dreams are, I know where they go on holidays, because, and I'm sure you have similar, I have interacted a lot with them. They mean a lot to me, so I look beyond the raw senses to what we call the cognitive, from the Latin cogito, I think. So gradually, as you go through your life, these erstwhile raw sensations, if you're making connections, the more you make, the more meaningful, the more significant, the more cognitive, the more personalized the world becomes to you through your connections. So it's a little bit like this. Here you see a brain cell on the left. You can think of it like a tree, if you like, and that's enabling you to have associations as shown by these bits of paper that are cognitive. And I would suggest that this is what understanding is. It's seeing one thing in terms of something else. Instead of just having a raw experience of a sensation, by seeing one thing in terms of another, by having more branches that make more connections, you have more personal significance or understanding of the world around you. Now, if that's the case, we can look at conditions where, sadly, that process has gone into reverse. And, of course, I'm talking about dementia. Alzheimer's disease is what I actually work on. Can we interpret this model, this way of seeing individuality, of understanding the world, in terms of brain connections? I think we can. This is a rather lovely Swedish lithograph of the ages of man or of women, showing, if you like, a cycle where you start off as a child and then almost recapitulate childhood again. Now, I'd like to give a word of warning. We do know that Alzheimer's disease is not, I repeat, is not a natural consequence of aging. It is instead a disease of older people, but it is a disease. Nonetheless, if you are a victim of this devastating condition, we can interpret it like this. Here you have the embryo, the fetus, and the early postnatal brain cell finally maturing in, as we've seen, to these lovely branches which enable you to make connections so you understand the world. But sadly, if you have dementia, what happens is there is a pruning back, an atrophy of the branches, so you make less connections, and you retrace the steps, you go back into childhood. So you become disorientated and confused. If you think that as you are growing, you are able to make sense of the world, because instead of being just a one-way street where you're bombarded by senses, you evaluate what happens in terms of what's happened to you before, and then what's happened to you before is modified by what's happening to you at the moment. You have this dialogue. You can imagine, if that's no longer possible, that you go back into a world where you lack the checks and balances of previous experiences. So you can't compare and contrast, you can't anymore understand what is happening to you. No wonder these patients are confused and disorientated. On the other hand, there's emotions like children, and like children you might have pleasure in things that the rest of us who are so sophisticated might find rather simple. But it's a world where you have less connections and it's strongly sensory. There's also ways of doing this on a more temporary basis. Since the dawn of humanity, we've done this, and this is a Greek vase depicting, I don't know if anyone is familiar with the work of Euripides, a Greek tragedian, and he wrote a play called The Bacchae, which I'm very fond of, and that concerned, as you can see on this vase, women getting very drunk, celebrating the god, the wine god Dionysus, and King Pentheus rather foolishly wanted to stop that, and as you can see from this vase, here they are, killing him, tearing him apart, because he didn't listen to the wise prophet who said there are two forces in man, the wine force and the bread force, and sometimes we say in English, to let ourselves go. I don't know if you say the same in Dutch. Do you say the same, let yourself go? Yeah, okay, so there we are. Now, I gather what you don't say in Dutch is you have a sensational time. As you know, in English, we use that a lot. Whereas if I said to you, okay, now let's stop this talk, let's go out and have a sensational time, you might want to do that. But if I said, tell you what, let's go out and have a cognitive time, how many times would you, no one would come, yeah? So we know that what's very interesting is, since humanity has stalked this planet, we've spoken of wine, women, and song, or its modern equivalent, drugs and sex and rock and roll. And of course, what you're doing there is you're disabling the connections. In the case of the ladies here, it's because they've taken a drug that will impair the chemical messengers that normally work between the brain cell connections. We talk about letting yourself go. You can do this not by taking drugs, but by putting yourself in an environment that is so fast-paced and so strongly sensory that you don't have time to worry about your mortgage or your exams or your job interview. I don't think these people are doing that. I think they're concentrating, or they're in the moment. They're living for the moment. Or for the more sedate people, this is Fragonard's swing. Now, all these are examples from different cultures of where you can manipulate your environment, either in some cases by foolishly taking drugs, or by putting yourself in a fast-paced environment, or one with a strong beat of the music that is stripped of all cognitive content. I don't know if you have it here, but we used to have sort of raising techno, where people go to clubs and just sort of have a loud beat of the music, you know, techno, like this. And it's a world that is strongly sensory. Now, what's fascinating is we pay money to do this, that we put ourselves in situations and what we have in common, whether it's skiing or dancing or sex or food or wine, one thing in common, you are letting yourself go. You are abrogating your sense of self. You are no longer self-conscious. And for some reason, we seem to like to do this some of the time. I'll come back to that. But for most of the time, here we are living our lives. This is downtown Oxford. This is what it looks like, where we all still wear medieval clothes and so on. The reason I want to show you this picture is because each person in this picture is on their own trajectory. They're living their own story. They're on their own narrative that is unique to them, even if they are a clone, an identical twin. And every moment you are alive, that experience, that unique narrative is building up and embedding itself on your brain cells. And that is why you are so special and unique, why there has never been anyone before with a brain, or perhaps more, a mind like yours, and nor will there ever be, ever again. So you are evolving all the time as this unique individual. So I'd like to suggest to you that the biological basis of the mind, and this is what I work on, I'm a neuroscientist, is this personalization of the physical brain through the unique dynamic configurations of your connections that are driven in turn by your unique narrative, your unique life story, building up and changing and in constant dialogue between your brain and the outside world. Now, if that's the case, what does it mean for the future? If, as I hope I've persuaded you, the environment is so important to what makes you the person you are, to your mind, what will happen if that environment is changing, as I will argue it is in this 21st century? With information technology, I would argue, and we'll see a little bit more detail in a minute, that we are merging the cyber world increasingly with reality. If we look at nanotechnology, the science of the very small, where engineering is on the scale of a billionth of a meter, so we're facing a revolution in terms of materials that would be as hard to understand as it would be for someone in the Middle Ages to understand plastics. That radical. What I think there with nanotechnology is happening is, as we're having devices that can interface with our bodies, that can actually be embedded in our bodies, that will monitor what's happening, we will start to blur the distinction between our bodies and the outside world. More of that in question time if you wish. And finally, biotechnology, which I'm not really going to go into, but where we're living longer and healthier lives, and therefore we'll be looking more homogenous, we'll be looking, wouldn't it be nice, all the same age, pretty much, and we'll be living a long time, we'll all be still working because we can work from home. So the old distinctions of one generation and another, which used to be what you look like, how healthy you are, whether you're working or not, and even indeed reproduction, because increasingly we're prolonging reproductive life. I would suggest at the limit what this might mean is homogenizing, flattening out the difference between one generation and another. One can think in the future almost that you grow up, you're an adult, and for your whole adult life, you're reproductive, you look young, you're healthy, and then suddenly you die. So if anyone wants to write a novel on this, I'll take 10% of the idea. Anyway, let's concentrate nonetheless. You can see that the theme here is one where traditional boundaries, whether it's one generation and another, whether it's fantasy and reality, whether it's your body with the outside world, and these compartments which we've always accepted forever since human beings have been around, perhaps for the first time they're going to blur. Perhaps for the first time those distinctions won't be as clear as they have been to previous generations. But what I'd like to concentrate on, because we are limited for time, is the first issue, because I think it's the most immediate and it's the most pervasive to all of us, and that is the impact of screen technologies. Now, this was one study done in the UK, and I don't know if there's any similar in Holland, but you can see here one survey of British children showed that between a child's 10th and 11th birthday, look at this, they spend 900 hours in class, just under 1,300 hours with their family, and under 2,000 hours in front of a screen. Now, if, as I hope I've convinced you, the human brain especially is sensitive to the environment, we are talking here of a new type of environment. We're talking here of 2 dimensions restricted to sound and vision, but that nonetheless, wherever it is enough to keep the attention, to compete with the 3-dimensional outside world to such an extent that it actually is, it wins. So let's think about what this means. Well, just to show that I'm not a complete Luddite and, you know, baby boomer kind of prejudiced old scientist, let me come in this book to you, Everything Bad is Good for You, where it argues that there are many benefits of screen experiences, especially for young people. And one idea that he suggests, Stephen Johnson, is that we've seen in many societies an increase in IQ scores. Because, he argues persuasively, the skills you need when you're engaged in an IQ test are very similar to those that you rehearse when you're playing a computer game. You're using mental processing within a certain time frame, you're looking at patterns and sequences, and you're reaching a very clear answer that's right or wrong. So you're solving a problem, you're using a mental process. But what you're not doing, and there hasn't been, an increase in insight into the economic problems of the world. There hasn't been an increase in the writing of symphonies. There hasn't been an increase in the writing of novels or insight into literature or history. So what we're looking at, on the one hand, is a skill, a mental process, but that is not the same necessarily as, say, understanding or insight. We must draw a distinction between information, this is information processing, information and knowledge. They are not the same thing, necessarily. What's another issue? Well, some people think that multitasking is good. I don't know if you'd like this in your bathroom, a lavatory that was like this, with many things you could do if you were bored while you're going through biological processes. But we know that, and perhaps no parents will be surprised at this, that there is less listening with more multitasking. You can see here brain scans with the subject just listening, and then with just seeing, and when you do both, you see less areas light up. So multitasking isn't of itself necessarily something I don't think to be desired. Something that is certainly not to be desired, and again I suspect it's the same in this country as elsewhere, is the increase, and I think this is a very telling sign, the increase for prescriptions of this drug, methylphenidate, which you may not recognize by its generic name, but if I told you this is what is Ritalin, then you might recognize it as the drug used for attention deficit disorder. And you can see here, again in the UK, prescriptions have trebled for this drug. Now, does this mean that doctors are prescribing Ritalin more liberally as possible? Could it mean that attention deficit disorder is now recognized as a medical condition, and it wasn't in the past, it's possible? Or could it just mean, and this is not mutually exclusive, that the environment has changed so that more young brains are displaying, or as a result of their screen experiences, having shorter attention spans? That's one possibility. Imagine if you are a young child and you are very sensitive to the environment, as you are, your brain is, and this is the experience you're going to have for some 6 hours a day. Everyone up if you were sleeping. Now, what do you think that does to your brain cell connections, I wonder? And especially if you're a young child that can't evaluate or interact, and then it's driving it with such force and speed, and then you go to school and you have to sit down for half an hour quietly, might you just kind of fidget a bit, you know? And then someone's going to come along and give you an amphetamine-related drug because you've got a disease, yeah? I mean, it's just one possibility. It's just one thought I'd like to suggest that we ought to look into. Yeah? What's unquestionable is screen culture is strongly sensory, as you've seen. It's full of what you see is what you get. How else can it compete with the environment? Of course it has to be supranormal, noisier, faster, louder, brighter, more surprising than the real world, as otherwise you'll go and live in the real world. So it's strongly sensory, and we know that children, as you can see, are very much driven by the sensory environment. As soon as this little child can no longer see the toy, he's looking off somewhere else. And as I know, when my brother was small, I have a much younger brother, if he dropped his ice cream and started crying, I'd say, look at the bird, and he'd forget about the ice cream and look up at the bird. You cannot say that to a depressed adult. Well, you can, but they won't thank you for it. Nothing much will happen if they're miserable, say, look at the bird. So that brings on to another issue, which is the lack of metaphor or abstract concepts. Again, with my brother, because I was nasty to him, I made him learn Shakespeare, because I thought it was quite funny that when he was 3, he could recite Macbeth. And one line in particular, out, brief candle, from Macbeth it is. Now, if you'd asked him what that meant, he would say, well, if you have a candle, you blow it out. But in the context of that play, it's a metaphor for death, the candle going out. How would you show a metaphor like that on a screen, I wonder? It'd be very hard to do. Or similarly, let's just take a very complex and interesting abstract concept. Let's take honour, a very interesting idea. If you Google on honour, oh, sorry, this is a British one, of course, there's the Queen, but you can do other things, there's honour. Now, if you showed that to a Martian, do you think they would understand what honour was? Just by looking at those images? I doubt it, because honour, I say, has to be nuanced in such a special way. So, what I'm concerned about is if we restrict ourselves to this Tom and Jerry world, this cartoon world of action, where what you see is what you get, where nothing stands for anything else, nothing is a symbol for anything else, there is no abstract concepts, are we missing out on how we understand things? So yes, we're promoting process as shown here, but what about content or understanding? For example, if you play a computer game to rescue the princess, as here we are, the noble princess Yukihime, she's been kidnapped, you're going to rescue her. Do you care about her? Do you care about the princess in the game? In the same way that you'll care about Princess Maria, say, in Leo Tolstoy's War and Peace? Probably not. Because here she's just part of the process, whereas the whole point of reading the book is because the princess has a past and a future. She has interactions, she has relationships. You're seeing her in terms of other things. She has a significance that the princess in the computer game does not, other than that she's an icon that is manipulated. So I think we need to distinguish between understanding and content, which you get, say, from books, or interacting with a narrative of life, and a world that's freeze-framed into a moment where you're having an exciting time, but it is meaningless, it doesn't have a meaning. Now, if that's the case, if you're doing games where you can just play the game again, or you're living in the moment, what about how you'll feel about things? So let's think about that. Now, these two little boys are not really interacting with each other. They're doing what lots of kids do, which is they're having a stimulating, exciting time, interacting instead with the screen. That's fine, but it's not the same as when you meet a person. When you meet a person, eye contact is vital, and the degree to which, as I'm sure many of you know, you sustain eye contact or you look away will vary according to how you feel about the person, how well you know them. And then voice and body language account for what we got here, 90% of the impact you're going to have on someone. And no one has quantified pheromones. And what about giving someone a hug, or even just shaking by the hand, or like this guy's doing, patting someone on the shoulder? All those things will determine how you feel about the person you're communicating with and how actually you feel. Words are only 10%. Now, eye contact, body language, pheromones, voice, physical contact, none of these are available on Facebook. So if you are spending most of your time, as a kid, having 900 friends you've got to talk to, as some people have, and you're spending all this time saying, hi, how are you? Hi, how are you? You're not rehearsing these very important interactive skills so that when you do it, you're going to feel pretty uncomfortable. It's going to be very aversive, and you will much rather go back to the cyber interaction, which is oh so much safer than the uncomfortable, online, messy reality of talking to someone in the flesh. I mean, it's bad enough anyway, even for people of my generation, but it's much harder if you've been brought up on Facebook, I suspect. Now, if that's the case, something like Second Life, it's very interesting that people with autism, that's to say who have an inability in any event to try and understand how other people are feeling, they are very comfortable in Second Life. And I would suggest to you that when we play Second Life, not what I personally do, we are all becoming autistic because the emphasis instead is on action. It's not on empathizing or understanding how someone else is feeling or using the clues that autistic people have a problem with, that most of us can do. None of us are using those clues because they're not there. So therefore, we're all sort of just looking at behaviors rather than at feelings. So are we in the future then going to see reduced empathy with people? I would suggest that we might, and the increase in autism might, in fact, substantiate that. But what will that say about you yourself? If you yourself are doing something that's trapped in the moment that I would argue is meaningless, that lacks significance, what will that eventually say about you as a person and how you see yourself? And if you don't have that narrative, if you don't have a past or a future, you're just in the moment, if you don't have a sequence that is quasi-permanent, are you permanent? So let's think a little bit about identity. Will we see a weaker sense of identity? Well, what I find very interesting is if you look at blogging, let me be very controversial and suggest that this is evidence. So here we are, 1999. I just have to tell someone about this thing my cat did today. We then progressed to 2004, Flickr. Oh my God, cat pictures. 2005, YouTube, moving cat pictures. And that pinnacle of civilization, Twitter, in 2007, 1 p.m., my cat just sneezed. 1:02, cat sneezed again. 1:04, cat hasn't sneezed recently, getting worried. Is this, what does this say about the person, do you think? About their sense of identity? Doesn't it remind you a little bit of, look at me, mummy, I'm putting on my sock. Look at me, I'm doing this. Because if you don't look at me, I might not exist. Could people on Twitter be an existential crisis, I ask, as a possibility? And is this indicative of people who are feeling a less than robust sense of identity? Another area that I think is very important, and bear in mind Obama said that the financial crisis had been due to greed and recklessness, is risk-taking. So let's think about risk-taking, because increasingly, if you're doing things that can just be done again, if you can play a computer game and you just play the game again, might this change people's attitudes to whether or not or how they take risks? And this is very important in many sectors and professions as well as in personal life. How you manage risk is a very important factor for the 21st century. Now, if you're a neuroscientist and you're asked to talk about risk, what you'll do is immediately go to neurological cases that are characterized by excessive recklessness. And I think the next slide is a slightly gory one. So if people are squeamish, you might just close your eyes for this slide. Oh, no, it's not, sorry. Caught you out. The next one. No, it's about to come on. But now you can open your eyes for the time being because it's a build. So this is the story of someone who was very reckless. His name was Phineas Gage, and he lived in the 19th century. He was a worker on the railway gang in the States, and he's earned his place in history because one day he was pushing down explosive down a hole with a big rod called a tamping iron, and what happened very sadly was the explosive went off prematurely and drove the rod through the frontal part of his brain. Now you might wonder why I'm telling you this story. You better close your eyes now because I'll show you what he looked like. Here he is. Actually, it looks quite nice. He's holding his rod there. And the more gory thing shows the degree of the lesion. But what happened was, amazingly, he came round and seemed just fine. He could talk and walk and see and everything just fine, amazingly. And he went back to work. And it was only then people noticed that he'd undergone a severe character change, including being very reckless. So this drew attention to this frontal part of the brain. You can open your eyes again now. Called the prefrontal cortex, as shown here in turquoise, which occupies in humans 33% of the brain. Meanwhile, in chimps, it's only 17%, showing that whatever it is that makes us human, and that's another story, another question, it may be related in some way to this exaggerated frontal part of the brain, which is very, very special in humans. In cats, it's only 3%, for example. So what do we know about the prefrontal cortex? Well, as we've just seen, if it's damaged, then you get enhanced recklessness. And just to show you the kind of studies that can be done, let me introduce you to Michael, who, if you like, is a modern-day Phineas Gage. He, as you will see in a moment from the film, was a victim in the Vietnam War of having shrapnel in the frontal part of his brain. And you'll see now his very different attitude to whether or not you take risks. So here's the movie.
X-rays revealed that shrapnel from the grenade had penetrated the front of Michael's brain.
Michael has undergone a rather dramatic transformation. Before his injury, he was a bright and very promising and assertive soldier. And subsequent to his injury, Michael became unemployable, made many mistakes in social behaviors and relations, and has to live a much more limited life now.
Demoted and eventually discharged from the army, Michael has been unable to hold down a steady job. He's now working under supervision as a hospital janitor.
I'm going to start out by giving you 10 chips. Each chip is worth 5 cents.
Dr. Jordan Grafman is trying to establish why Michael's life has fallen apart. What aspects of his mental abilities have suffered because of the damage to his frontal lobe?
8, 9, 10.
This gambling task is designed to test his ability to weigh up the likely consequences of his actions. The point of the test is to see at what stage in the game he decides to stop.
Do you want to stop or do you want to continue?
Continue.
High cards, Mike wins a chip. 10 or less, and he loses one.
Continue.
The cards are deliberately arranged to give him a good winning streak, followed by a steady run of losses. Normally, people stop while they're ahead.
Continue. Should have kept it. Continue.
That's it. We're at the end. You gave me back all your chips.
Okay, so that's an example of the kind of test that can look at risk-taking. Now, what's very interesting, you can do a similar test and show another group of people who have not got damage to the frontal part of their brain, but who show similar behaviors, and here you can see them. They are obese people. Obese people. Now, this is going somewhere, believe me. So obese people will do similar risk-taking in a gambling task, and we know, and sadly this is going to be a feature of the future, look at the number of adults and children who are currently overweight, that this is associated with low activity in that frontal part of the brain. So they haven't got physical damage, but it's less active. The cells there are less active. It's lower metabolism in that frontal part of the brain. Body mass index is BMI, of course. So the higher your body mass index, which means the heavier you are, the lower the activity in that frontal part of the brain. Another group of people, again who are reckless and with an underactive prefrontal cortex, as shown here, are people with schizophrenia. Now, schizophrenia, just to remind you, is a condition where people are easily distracted, where they see the world in bright, glowing colours quite often, where they make rather flimsy and idiosyncratic links between one thing and another, where often they feel the outside world is coming in on them, and which in many ways is similar to childhood. We know that in both cases, children and schizophrenics are easily distracted, they have a shorter attention span, they cannot see one thing in terms of another. So rather like my brother when he was small couldn't understand that a candle was a symbol for life, so similarly Proverbs, schizophrenics and children can't tell you the real meaning. If you say, people who live in glass houses shouldn't throw stones, a schizophrenic will interpret that by saying, if your house is made of glass and I throw a stone, your house will break. They don't get the connection. And similarly, in both cases, there's an underfunctioning prefrontal cortex. It's very interesting. This frontal part of the brain only comes fully on stream in late teenage years and the early 20s. It's very late to develop. So, in that sense, it reflects evolution. So what have all these things, as you can see here? So what have all these things got in common? Well, we can see that even the doctor that treated Phineas Gage pointed out that people with an underactive prefrontal cortex were childish. He said that Phineas was intellectually feeble, capricious, childish, impatient of restraint, a child in his intellectual capacity and manifestations. So, let's think about what these different things can have in common. Children, eating, gambling, and schizophrenia. And I think the clue comes from this painting, this very famous painting from a schizophrenic patient, showing top left a cat that anyone would recognize as a cat. But as the disease progresses, you can see bottom right, nothing that could be called a cat by anyone's imagination, I don't think. If I showed you just that last picture, that abstracted picture, you wouldn't recognize that, I don't think, as a cat. So in a sense, what we see here is a progression from cognitive to sensory. And what I'd like to suggest to you is what all these conditions have in common, linked to the underfunctioning of this frontal part of the brain, is the senses are trumping the environment. The sensational is trumping the cognitive. We know that anyone who eats knows the consequences of eating, but the thrill of the food overrides that for many people. Anyone who gambles knows the consequences of gambling, but the thrill of the horse going past the post or the roulette wheel or the dice, that experience, that thrill, trumps, is better than the consequences of losing all your money. So could it be As with children, then what we're visiting here are situations where the sensory unusually dominates over what would normally be the consequences, the cognitive. So let's think now about the screen technologies. The screen will offer you high arousal, otherwise you wouldn't be doing it. For many, there's addiction. And finally, many find it very rewarding. Now, what's very interesting in neuroscience terms is that all these phenomena, if you like, are linked by one chemical messenger called dopamine. And we know that dopamine is at the base, like a fountain in the brain. And we also know that, guess what? It will inhibit the prefrontal cortex. So we can put these things together and relate that to, I think, the screen technologies. I'd like to suggest there's two modes for the human brain. We can think about when the prefrontal cortex isn't fully engaged and when it is. This is where you'll have strong feelings and emotions. Here, the thinking will dominate. We can call it sensory versus cognitive. Here, you're living in the here and now. Here, there is a past, a present, a future, a narrative. Here, the external environment is driving and determining one moment of consciousness to the next. Here, the internal perceptions, your notion of a sense of self or identity will do the driving. Here, there is little significance. What you see is what you get. There is no symbolism. Where here, there is a personalized meaning to how you are experiencing things. Here, you've let yourself go. Here on the left, of course, this is what happens with wine, women, and song, or having a sensational time. Here, there is a strong narrative, a strong sense of self. Here, there's no time and space, you're just there. Here, there are clear episodes as part of your memory. This is mainly characterizing infants and children. This is older children and adults. This is more dopamine. This is less dopamine. Now, this has been going on for a long time, and as I say, sometimes when we want to spend money or relax or let ourselves go, we'll put ourselves in scenarios that enable our brain to more like on the left-hand side. But the point I want to make is that that sensory here and now world, if that is all the time, that's one characterized by the computer cyber world. And if a young brain is permanently doing that, will they never rehearse those other things? Will they always stay there on the left-hand side? What one can imagine, and this is a model we're working on in my lab, is that you can imagine working with a screen, experiencing screen activities gives you fast responses. And that makes you very excited. And we know that high arousal is linked to dopamine release, which is also linked to reward-seeking and addictive behavior. Every psychotropic drug, irrespective of what it is, has the final common path of causing the release of dopamine in the brain. Excessive dopamine, as we've seen, causes hypofunction, inhibition of the prefrontal cortex. Therefore, we will have less brain cohesion because that part of the brain normally pulls in, normally accesses more other areas of brain than any other. This will simulate conditions of childhood or schizophrenia or obesity where the overriding characteristic is sensation over cognition, and that in turn will mean the screen will hold a greater appeal than the messy, three-dimensional world with all its symbolism and significance and its history. And so the cycle will repeat. So that's what I'd like to suggest. Now, if that's the case, what does the mind of the future look like? Well, good and bad. There'll be higher IQ, shorter attention span, improved short-term memory, icons being important rather than ideas, a sensory emphasis, less empathy, less risk-averse, that could be good or bad, less sense of identity. Now, some of those are good, some are bad, and my own subjective value judgments are the green are good, the red is bad, and the yellow is neutral. So you can see it's a complex issue. This is not a question of are computers good or bad. It's something we have to unpack and think about as a society. Certainly, this legitimizes my otherwise Luddite concerns. This is from Eric Schmidt, the CEO of Google. I worry that the level of interrupt, the sort of overwhelming rapidity of information, is in fact affecting cognition. It is affecting deeper thinking. I still believe that sitting down and reading a book is the best way to really learn something, I would say understand something, and I worry that we're losing that. So I think this is something we really can't just dismiss. We do need to think about. How can we convert from information, that is to say isolated facts, isolated experiences, into a network, into a personalized framework, into a connectivity that makes you the individual that you are? Well, I'd like to conclude just by 2 minutes. Have I got a few minutes? Yeah? By thinking about that, because let's think about people with brains that we might admire. Einstein, Shakespeare, Mozart. What did they have? Well, they didn't necessarily have good memories, these people. What makes them so special? What's the common factor? The whole common factor that these clearly very, very talented people had was that they're very different from each other. They had highly original brains. So it wasn't had anything in common, it's that they were completely different from anything else. They had a new insight into the world. So what I'd like to suggest is surely the way forward, or what we need to do in harnessing those technologies, is not just to help people understand, but even better, to understand from a unique perspective that we could call creative. So let's think about the neuroscience. Here's my idea. Let's think about the neuroscience of creativity. Well, let's start again back to the brain and look at people that claim they're creative. Children, certainly, they paint lots of pictures and are more creative than the average adult, possibly. And we know that their connections are still growing. In neurodegeneration, again, one can recapitulate that. And one of the very small positives of dementia sometimes is that people that hadn't been creative suddenly have a spurt of creativity, and of course they're losing their connections. People often claim they're most creative when they dream, and there the connections are not very strongly working because they're not driven by the outside environment. Some people think that schizophrenics write poetry or paint in a way that others wouldn't, is creative, and they have dysfunctional connections due to excessive amounts of dopamine. People on drugs will sometimes say they're creative, and there again, they've actually taken external agents that impair their connections. Now, I'm not saying that any of these conditions is a guarantee to be creative, or that if you're creative, you have to be any of these things. But could this give us a clue, which is a weakening of the connections? Could it be that creativity actually was an under-functioning prefrontal cortex? Well, I don't think so. Let's think about that. Here's an example of creativity, and I'm not a painter, and I apologize to any artists in the audience. But the first thing that's happened here is that dogma has been challenged, convention has been challenged. People don't look like this. They don't look like this. Similarly in science, you challenge dogma. You say, but why are we assuming that these two things, A and B, go together, or X and Y go together? So surely part of creativity is to deconstruct pre-existing associations or normal or conventional connections. And that might indeed be helpful if you've got those conditions I've just suggested, childhood, schizophrenia, and so on. Perhaps that is useful for that. But there's more to it than that, isn't there? Let's think about this. This is a painting from someone called Phoebe Collins, age 4, the daughter of one of my postdocs. Now, Phoebe has indeed complied with that first condition, because sheep don't look like this. It's supposed to be a sheep. Sheep don't have purple heads and pink bodies and turquoise tails and no feet. Right? But nonetheless, this is interesting because Phoebe has done what sometimes when people are creative have done. She's brought together unusual associations. But still, I don't think anyone would want to see this painting or expect to see this painting in an art gallery. Whereas this one, certainly in the UK, is very famous. This is Damien Hirst's Pickled Sheep. This is a dead sheep in formalin, which is in the art gallery. So what's the difference? Why is one sheep regarded as art and the other sheep not? I wonder. Could it be that Damien Hirst's sheep does a third thing that Phoebe's sheep does not, and that's the crucial clinching factor? Let's think about that. First, yes, we deconstruct to abstract sensations, challenge dogma. Then we bring together new and unusual associations. But the third thing is the most crucial, in my own view, is that those new associations have to have a meaning. They give you a new insight, a new way of looking at the world. Whether you like it or not, it's different from what happened before, either for yourself and or the people who are sharing what you've done, so that you say, indeed, Eureka. Now I understand, now I see. This is a new way of looking at something. And the same in science. So it's three things: deconstruct, unusual associations, but that new combination has to trigger many more associations. And the more associations it triggers, the more deeper the understanding. So if that's the case, what are we going to do in the future? How are we going to find fulfillment in life? I think we have to be alert to this transition that is currently underway from things that have significance to just feeling things and just being in the moment. We need to think about how we're going to manage risk, that balance between being reckless and being risk-averse. And how can we help people develop a sense of identity? How can we help them recognize themselves as individuals? Well, my own view is we should devise situations that promote creativity. So that is the most exciting way. If you're having an idea no one else has had, or you're seeing something no one else has seen, that's what someone said science. It's to see what everyone else has seen, but think what no one else has thought. If you can do that, then I think you're on the way to having fulfillment and a sense of identity, as well as being incidentally useful to society. So this is a shameless plug for my book, available on Amazon, I don't know how much it is in euros, which explores identity in the 21st century. I think that what's very exciting is that science and technology has, for the first time, en masse, given us longer and healthier lives, has given us more hours in the day, freed up from mere survival, being warm, looking after the kids, to actually doing something that at last we can do, which is, if we get it right, exploit our minds, push our minds to have our true individual potential finally realised. Thank you very much.
Thank you for your thrilling presentation. Thank you very much. There is a little bit time left for some questions. I promised the audience that there would be an opportunity to ask something. Is there anyone who wants to ask something about the story we've just heard?
You can ask in Dutch and I'm sure you'll translate it.
Of course. Oké. U kunt het in het Nederlands stellen of in het Engels, wat u wilt.
Nou, wat moet ik nou tegen mijn kinderen zeggen? Mogen ze nou wel of geen schermpjes kijken en hoe lang?
It's always awful when people laugh and you don't know what they're laughing at.
I will tell you, she's worried about what to tell her children, about which number of hours is still, well, in your opinion, good to spend behind the screen.
Okay, it depends. It's a bit like saying, is a car good or bad? Yeah? And of course it's everything. It's both. It's what you do, it's what you want to achieve, it's what your kids want to achieve, and it's what they do when they're not on the screen. So obviously screen technology is a part of 21st century life, like climate change is. And I think the term mind change could be equally appropriate, because like with climate change, where there are many different issues and questions and many different attitudes, and some people think we're doomed and other people think there's not a problem and other people think science can help, I think that this issue is as complex. For example, are we talking about playing computer games and the attitudes to risk? Are we talking about social networking sites and human relations? Are we talking about how we use Google and information versus knowledge? And I think what we need to do is to really nuance it more. We need to think more about each of these separate issues and not say, oh, computers are bad, computers are great, yeah? Which is, I think, doing no one any service at all. We need to think very carefully about all these different things, and you as a parent and we as a society, we need to decide, what do you want your kids to be? What kind of people do you want them to be? And that's not obvious, because we are living in a very different world from the last century. What kind of people will make good citizens for the 21st century? What kind of people will use this technology to do what? And what are we going to do with all this leisure time? All this time when after 50 you could be living for another 50 years? After kids go, what are you going to do? Just go yuck and wow and yuck and wow. So what are we going to do? Yeah? And these are very big and exciting questions. So, and it's you in the privileged position, powerful position of being a parent, who is in charge of the next generation, who are going to look at the rest of us when we're ill and old. Yeah? So it's very important that we get it right and we really make the most of it. Rather than, so I can't answer your question in a simple way, other than say the more we can talk about it and think about it, the more neuroscientists and educationalists and teachers and software designers can all work together. We need to harness the technology. We can't just sleepwalk into this world. So I think the most important thing, and what's very exciting for kids, is to understand how the brain works. They love understanding that. Yeah? And ensure that they have a three-dimensional life as well as a two-dimensional.
Good, thank you. Anyone else? Yes, here. Wilt u in het Nederlands of in het Engels?
Thank you for your excellent speech. And on the issue of increasing your brain branches, I would like to ask you, what are your recommendations for the educational system in this sense?
Yeah, I think this is very interesting because certainly in the United Kingdom, education is still in the last century. People are still using issues like you have to learn facts. And especially in science, this is something I'm very aware of, it's now possible to learn facts, you download them, you pass them on, or you cut and paste a bit, but you don't really understand. And in science especially, I'm aware that people don't understand what they're doing. Everyone is happy because you are providing answers that tick boxes. But it's very interesting to try and develop understanding with people. And I think that, in a sense, turning kids into second-rate computers, where they just have facts and information, is not really doing anyone any good. And especially now, where it's so easy to access facts and information, we should really be thinking about new ways in which we can help people put those facts together in a framework and how we can understand them. They're not doing that at the moment. because our government just want to show how good they are by getting people to pass exams, you know, and have everyone will be above average apparently at university. So you know, that I find very short term. And my own view is that really what real education is understanding, really, and how we can do that. And that is not as easy as just telling people facts.
I guess there's more about all this in your book.
Yes, I did. Yes.
Okay, one more, because we're running out of time. Okay, I think that's maybe for the best, because you have to rush off to the airport. Thank you very much again.
Thank you.
Yeah.